All right, hello everybody. Uh, this is me and Jacob, and we're going to talk about the compliance operator with a fancy title such as automating security compliance checks one scan at a time. Basically, what we're going to do is talk about an operator we coded for OpenShift. So if you're interested in the buzzwords Kubernetes, OpenShift, security, then this is your talk. Else, this is recorded. You can go to any other thing in the meantime. Uh, So we have a hefty agenda today, or quite big. So we're gonna go through it quite fast since we're time constrained. We're gonna answer hopefully these questions, but if we don't answer them thoroughly enough, you can always ask in the Q&A, or we're actually happy to answer offline as well. Who are we? Who are these funky people that are talking to you? So first of all, I'm Juan Antonio Soria Robles, and that's a handful, so just call me Oz. I used to do OpenStack. Now I'm doing OpenShift, and it's a lot of fun.
Okay, I'm Jakub. I'm a Czech person who lives in Sweden. I'm also working on OpenShift security and compliance with us. And before that, I've been working for quite a few years on SSD and FreeIPA. Okay, so first we're going to tell you why are we even doing this work. Compliance is required in some industries. If a product, in this case, OpenShift, is not compliant, it means we cannot sell. From the other side, it means that users cannot even deploy OpenShift. It's never fun reaching a compliant state with any system, and with the cluster, it's even less fun because the clusters tend to be big. There's many machines. There's the cluster plane on top of that. And what makes this even less fun is that Kubernetes as an upstream project is really fast moving. There are upstream releases every 3 months. So if you do all the work yourself, it means that when you are done with getting your cluster compliant, there's another upstream version, and you can as well start over. The standards that the cluster is supposed to be compliant with are also not written in exactly easy language. The language the standards are written in sounds a bit like a mix of technical English and lawyer English. And much of the work is actually sitting down, reading the standards, and interpreting them from that mix of lawyer English and technical English into something that can be applied to the cluster, some technical configuration changes. So this is not easy work, but it still needs to be done. So the goal is to enable OpenShift in high security environments. Think banks, insurance companies, governments, militaries, stuff like that. We are going through the compliance controls through those standards and codifying them from the standards into something that is called compliance content. So compliance as code. We'll talk a bit about that later. We're also developing this tool called Compliance Operator that is able to, with the help of OpenSCAP, is able to run this content, evaluate it, show results, and act on them. This way, you can, with the help of the compliance operator, you can escape all the tedious work that I talked about in the previous slides and automate as much as possible. At the moment, the standard we are looking at is called FedRAMP Moderate. It's part of the NIST suite. In the future, we're also going to look at some other standards like FedRAMP High or Common Criteria. But at the moment, FedRAMP Moderate is what we are working on. One remark is that this work might be interesting for you even if you are not interested in those standards in particular. It's not like we are doing work that is just going to be used by the US government, because the FedRAMP and NIST standards are typically used and mandated by US government. But many other standards used around the world, like the Australian Essential 8 or the French government standards, sort of base off the US government standards. The US government standards are sort of the standard of standards that others are looking up to. There are two operators that we are working on. The bigger part is the compliance operator. There's also a sort of smaller operator called file integrity operator. We will not talk about it in much of detail in this talk. Just take note that it exists. The file integrity operator helps us identify any unwanted changes on the file system that might be result either of an admin doing some change manually or even of a break-in.
All right, so now we're going to talk about what did we actually do here, right, given a small overview. So as was previously mentioned, and what is the topic of this talk, is that we did take a big part in the compliance operator, but really the functionality of this whole thing is basically three things. Right, the compliance operator, which enables compliance checks in OpenShift and in a cluster level, but that leverages OpenSCAP, which is a NIST certified scanning tool. And what is a scanning tool if you don't have security content, right? So the scanning tool leverages checklists about that tell you what to check, where to check it, and so on, and give you more information about the sort of stuff that you're checking. That is called content, right? That content comes from a project called Compliance as Code. And so there you will see stuff like what's the severity if you find an issue, or what's the risk score, and so on, right? So it's these three big pieces that form the whole of what we're working on. So our team doesn't do a lot in OpenSCAP, we just leverage it, but we do build the operator and build constantly content in order to address the security needs for OpenShift. Right. So basically, the operator proposes several custom resources, and as you can see, there's many. But don't get overwhelmed. Really, what you should care about are the following. Right. So this is what helps you meet your compliance needs, and we will go through them in a little bit. So basically, it all starts from defining what do you need to comply with. Right, so you have a profile, and the profile will be a collection of rules, and those rules tells you, for example, you should enable audit logs, or you should do X or Y thing, right? You can tailor those profiles, and finally you can set scan settings, right? So these are the stuff that you would be able to encode into objects in Kubernetes to do the checks. We'll go through them. So as I mentioned, the profile contains metadata about what you're checking. It contains a description of what you're checking and a big collection of rules. In this case, I just put 3, but in reality, for the Essential 8, there's tens of rules. For the moderate profile, there's hundreds of rules even. A rule, as I mentioned before, is what exactly are you checking? So we add extra metadata to it, like what security controls are you addressing with this rule, or what's the title, and so on. There's even more data, such as a verbose description, what's the severity, why are we even checking this, the rationale. And finally, what a lot of people care about is how do you even fix this thing, right? So we encode this information as well in the rule. In our case, for the operator, most of the objects will be Kubernetes objects. In this case, as you can see, it's a machine config object, but in reality, it could be any, right? So we have this information as part of the rule. We give several vendor-approved profiles out of the box, right? So you don't need to create your own profiles from the beginning. And these are being constantly tested in CI as well, right? So this is stuff that we provide out of the box to try to provide you a bit more value. What is a profile, though, without being able to tailor it, right? So every organization is different. Everybody has their own needs. And so we also give you the ability to easily modify a profile. Like maybe you want to disable some rules, maybe you want to enable extra rules, and tune some variables as well. So you are able to do this too. Finally, what you want to know is, or set, is how am I going to do the scans, right? So you might have a policy of I'm going to scan once a month, or I want to scan every single day or every hour, right? So you are able to do this, right? The raw results needs to be stored somewhere, so you are able to set these tunables as well. How are we going to rotate those results if you want to rotate them? How much storage are you going to allocate to that? So where am I going to schedule these checks? So master nodes, worker nodes, and so on. So this is what this is for. Once you have these policies defined, right, what profiles do you need to comply with, what are the scan settings, then what you want to do is execute, right, specify your intent. And you do this with a scan setting binding. So tell the operator what you want. And it's, as it says, it's just a binding, right? So I want to comply with my tailored profile, but also with this other profile right here. I want to tie them to the specific scan settings. And that's it. The operator will do the right thing and start doing scanning. All right. What you want to do next is check out how your scan is doing. So you do this with this compliance suite object. Uh, it gives you the phase where you're at. Let's say the scans are running, but at some point they're going to get to the phase done. I give you a result. It also issues events with the results, so you're able to even listen for this and as an SRE be able to react to this. So it gives you several useful information that you're going to need for your scans. And finally, of course, you're going to get the results out of the compliance suite, right? So we expose several objects for this, like compliance remediations, which tell you how to address the results, and you can even apply them automatically. You have the check results, which we're going to go through in the demo. And you also have raw results, which are results that auditors are used to seeing in a specific format and so on that some governments take. So those are generated too. But we'll go through this in the demo a little bit.
Okay, and next we're going to describe how are these scans actually run, and we're going to go bottom to top, so starting from the content, which is on the next slide. Okay, so the content is built from a separate project, separate repository that is called compliance as code content. And this repository contains all the checklist, all the definitions for a product. So a product is an OCP or a product is Argos. You can think about this repository as a dump of the interpretation of the controls. We talked earlier that the controls might not be easy to interpret. So there's a lot of kind of tribal knowledge in the heads of people who work in this space. And this repository takes the tribal knowledge and actually puts it down in the code so it can be reused and run over and over and over again. So there's the compliance code content project. The result of all these rules that are written in that project is a huge XML, one per product. And there's one XML per OpenShift, one for Argos, and so on. We take these XML files and package them in a container image. You can either use things, so the files from that container image directly, but that's not very user-friendly. So we have this profile bundle custom resource that sort of wraps the container image and can be used instead of pointing at files in the container image and link to some container repository. When any change to the profile bundle object is scheduled, the operator schedule is detected. The operator schedules a deployment that reads the files from the container image, parses them, and creates the profile and rule objects. And these are also meant mostly for usability, so they represent parts of the content, so primitives in the content, and display the metadata that are also written in the content, such as which control is this rule addressing, what severity does it have, what does it actually do? There's a human readable description. So the bottom line is that there's a profile bundle custom resource that creates other objects that are meant for administrators' usability. Okay, so once we have these primitives that allow us to run the scans, we can actually run one. The bottommost custom resource that represents a scan is called a compliance scan. This resource is typically not meant to be used directly. It can be, but it's not recommended. The reason is that this custom resource needs all the low-level parameters to be running OpenSCAP. There's a profile ID, which is this long string. It needs to know the image to get the content from, the content file, so that's the data stream file path, and so on. When this compliance scan object is detected, the operator has a controller, which is called compliance scan controller, that reads the compliance scan custom resource and schedules a scanner pod on each and every node. The scanner pods run OpenSCAP. Once they are done, the OpenSCAP produces results, and we put the results into config maps. There's actually two kinds of results. One is sort of just pass-fail per rule. We put them into config maps for further parsing. And then there are results that are called ARF results. These are these huge XML files, think tens of megabytes. And because these are too big to be put into config maps, we are actually talking about that a little more in a little more detail later. We also schedule a deployment, which we call a result server, and we put the raw ARF results from the scanner pods into a persistent volume where they can be accessed later. It's useful to note that because we are a security team and care about security, there's a ephemeral PKI created to make sure that the results are stored in the persistent volume securely. Lastly, there is a special pod. Once the scan is finished, only one per scan, that takes the config map results that were created by the scanner pods previously, parses them, and generates other custom resources that represent scan results, remediations that actually let you correct the findings. And in case the results are not consistent between nodes, the aggregator can also detect inconsistencies, which is something we'll also talk about later. Okay, there's two types of scans, two basic types. One is a node scan that scans the actual node on which the cluster is running. So think Argos typically. These node scans must run as a privilege pods because we are looking at the node configuration. So the pod actually mounts the node file system into a directory and runs OpenSCAP in this chroot mode where it looks at the directory of the node. And in this mode, there is one OpenSCAP pod for each node. The other type of the scan is called a platform scan, and this actually looks at the cluster configuration, so at the OpenShift or Kubernetes configuration. There's only one non-privileged pod because it doesn't need to look at the host configuration and only looks at the cluster resources. Before this pod runs, it actually also spawns an init container that we call API resource collector that looks at the OpenSCAP content, checks out which Kubernetes objects the content needs to be checking, like with config maps, is it looking for to check Kubernetes configuration, and prefetches them prior to actually running the scan. In this case, in this platform scan, OpenSCAP is only run once and doesn't actually has access to the host. So that's why we actually have the two kind of scans, because the node scans need to be privileged, need to look at the host file system. The platforms one don't. Going one step above, there's the compliance suite object that is sort of abstraction over several compliance scans. And this is an object that you might be actually using so it's considered user-facing, at least more than the compliance scan. There's also a corresponding controller called compliance suite controller. When the controller detects a compliance suite object, it reconciles it, takes a look at what scans are listed in the compliance suite, creates the scans, and then keeps track of them. There's two main uses of the compliance suite. One is to present the collection of scans and also present sort of aggregated view of all their statuses and also kind of overall status of all the scans as one attribute. And the suite also has some other suite-specific attributes, like whether you want to run the suite repeatedly on a schedule. So there's a cron-like schedule that you can set and say something like, rerun this scan every Monday. So you keep track of compliance of your cluster continuously. The other thing that you can set in the suite is you can actually say that you want to trust us and automatically apply all the remediations as the findings are as the compliance checks are found. The idea behind this is that you just create the suite, it runs, and at the end, your cluster should be compliant. Going even one step above, this is actually our recommended custom resource to interact with the compliance operator. It's called setting binding. The idea behind this setting binding is to improve usability, because both the compliance scan and the compliance suite still let you or enforce you to list all the low-level details that are very OpenSCAP specific, like what is the ID of the profile, where does the content come from, like which container image. The scan setting binding is much more user-friendly in the sense that you just express the intent of the scan, and you only reference the other helper custom resources like the profile bundle. So in the end, you don't have to know the OpenSCAP details like what is the profile ID, what is the content path. You just reference the other helper custom resource, and everything else is done for you. Okay, as I alluded to earlier, the OpenSCAP results, at least the raw results, the very detailed ones that auditors are used to seeing, can be very, very big. And because config maps, or rather etcd underneath them, have a 1 megabyte limit, we cannot store the results in a config map. So what we did was that there's this result server deployment that mounts a persistent volume, and each scan pushes through HTTP put, I think, the raw ARF results to this result server. And the result server stores them on a persistent volume, and then later, once the scan is done, the administrator can mount the persistent volume into their helper pod or whatnot and access the results they are used to, even though they are very big.
Right, so we're going to go through a small demo just to try this out. And you can look at it from this link, but let's take a look. Here it is. Right, so to try to not get a demo effect, I could have this into a demo.sh, but yeah, let's check it out. So as mentioned before, we have some profiles that come out of the box. Some of these are in development, but anyway, there's some out of the box profiles there. We're going to look at one of them. In this case, is the Essential 8 profile. As you can see, there's tons of rules. There's a description of the profiles and the rules that we have here. So that's it. If we want to check one of the rules, you can do so. It'll give you a bit more information that you need to know, such as the available fix. There is some metadata that is a bit verbose, like the managed fields, but please ignore that. And right, now the next thing to do is to take it into use, right? So we want to define some scan settings, something very basic that I want to run, for example, every day at 1 in the morning, my scan. And let's just apply that, right? So we want to comply with, I think it was essential 8, right? Essential 8, and with the scan settings defined. And that's it. We create this scan setting binding, and we can sit back and just let the operator do its thing, right? So you can start looking at the status of your compliance suite, and it's going to tell you the phase and the result of it. In this case, it's just running, but there is no result yet. As we move forward a little bit, it goes to aggregating phase. As Jakob mentioned, it just gathers all the results and checks for inconsistencies. And finally, it's going to get to done. In this case, our cluster was non-compliant because it came out of the box. And now we're going to check the results, right? So it gives you a big list of results. A lot of them are based on some custom audit rules and some other networking-based settings, which can be easily fixed. So yeah, you can even look at them, filter them with a label, as with any Kubernetes object, right? So if we want to explore one of the results, it'll tell you a bit more information about it. What's the severity of the issue? What's actually going on? How you can fix it? And we want to know what to do about it, right? So we have a lot of remediations here that came as part of your scan, right? So we can just apply one. As you can see, one of them creates a machine config. We're going to apply that one specifically. And what we do is just set apply to true. So the remediations controller will actually do its job. And that'll create an appropriate machine config object. And you can check it out even, which is what we're going to do right here. Something really simple as seen before. It just sets up an audit rule here. But these will let the machine config operator do its thing, because in OpenShift, everything is an operator. But eventually, this will trigger an update in all of the hosts that apply to this. I think it was the worker nodes, if I remember correctly. And this rule will eventually be addressed, right? And we also created some persistent volumes, and this is where the raw results are, right? And this is it. There's a lot more stuff to it, but we're not going to go through the whole flow because we're a bit time limited, unfortunately. And right now, let's check out the challenges, right? So one of the things that was an issue with us was the ARF results, right? We did stumble upon that limit, even if we used bzip to compress the results. We did have that limit with etcd. We also had the limit that not all of the persistent volume drivers or implementation support read-write many, so you can't mind them in the scan pods. So what we decided was to create one server that would just receive the whole thing, right? And as mentioned before, they do it through HTTPS, actually using MTLS, so no rogue results come into play, right? So that's basically what we did.
Okay, another technical issue that we had to solve was displaying one result per many nodes potentially. So if you're scanning the cluster, you're not interested in having 10,000 results if your cluster happens to have 10,000 nodes. Typically, what you would scan with OpenShift is you would scan a machine config pool, right? In a machine config pool, the machines should be identical. But what if they are not? If the aggregator pod, which looks at the results of all the scans and tries to represent them with one Kubernetes object, realizes that the scans are actually differing between machines. The scan is marked as inconsistent, so that the administrator already knows that this has happened. And then the aggregator pod looks at all the results in the inconsistent list. So one of them might be failing, the other might be passing or something. And the aggregator tries to find a consensus. So it tries to find the most common state and flag the outliers. The outliers and the common state are presented as labels, so you can filter and search everything quite easily. And if possible, it's not possible always, but if possible, the operator still tries to create the remediation, which lets you correct the finding that the OpenShift scanner had found. And if the remediation is created, you can still, in the Kubernetes way, just keep on converging to the desired state. One other issue that we were solving was was an issue with content updates. So the remediations are stored as Kubernetes objects. Very often they are stored as machine config objects for node level scans, or as config maps for cluster level platform scans. You can patch these objects, but even if you patch them, you typically still need to replace the whole payload. But then the issue comes, what if the defaults of the cluster or some package on the nodes change? Or what if the remediation was wrong in the first place? In this case, we would update the remediation object, but we would just not rewrite it outright. We still want to give the administrator the chance to review what has changed and what they are actually applying to that cluster. So the remediation in this case is flagged as outdated, and the object at that point contains both the current, so kind of pre-update contents, and the updated ones. And the administrator would then go edit the object or patch it or process it in whatever way they want, and review the new updated contents and apply them as they see fit. So when are we actually going to release the operator? The operator is coming to OCP 4.6. At that point, it will be available in the operator hub as a Red Hat operator. What is important to note is that the fact that the operator is there does not mean that all the content is there. So please don't take a message that the compliance operator will be available in 4.6 as 4.6 is able to be FedRAMP compliant. The operator will be there. The content will be released after 4.6 is out. One other note, the compliance operator is a new project, and as such, it requires some quite new Kubernetes APIs, so we don't support older releases.
Right. So now a lot of people have asked a lot of questions regarding the operator. Let's try to address some of them here. So why compliance is code, right? Basically, one thing that we notice is that while we could do our own thing, like a lot of people have done, we prefer to enhance communities, right? So this project already has an active community. It's not only hardcore Rails shops, as some people have asked and noted. There is content for Ubuntu, there is content for SUSE, and for other applications as well, right? I think there is Mac content even, so we prefer to help out and enhance the existing community instead of just doing our own thing. A lot of people have also asked us, why didn't you use Open Policy Agent or OPA? And the fact is that the compliance operator is not a policy engine, right? While you would think policy, it might be a buzzword that is used by both operators, they are different things. The compliance operator does compliance scans and helps you get there. The Open Policy Agent helps you enhance authorization throughout your cluster and might aid you in audit as well. But it is a very powerful project on its own, and I don't see them competing. I actually think and hope that in the future, the compliance operator could check and deploy policies that are taken into use by OPA to enforce compliance rules through authorization, right? So that would be great. Can I try this in 4.3? And you can't, unfortunately, as Jacob mentioned already. We use fairly new objects, and not everything will work, unfortunately. what about RHEL? I mean, we've been talking a lot about CoreOS, but the fact is that you can still do your standard compliance scans with RHEL, right? And that is possible. But what we try to do is automate, and we might try to test it out in RHEL in the future. But we've been focusing, right? That's the main thing. And also, as Jacob mentioned, that the content is gonna get here later as well, right? So with the compliance operator, you're not necessarily compliant. You still need to come up with new content, but depending on your organization and your responses, and we still need to finish writing up the content for the standards that we're focusing on, right? So that'll come. You just gotta be patient. And yeah, what's next? There's still a lot of work to do. Of course, content. That's the main focus. We need to write more checks and remediations for you wonderful folks to use. Another thing is that we're doing Rackham support. We already have support for issuing events that Rackham consumes. So with this multi-cluster advanced cluster manager, you are able to deploy compliance operator profiles and so on. So you can specify the intent of, I want all of my clusters to be FedRAMP compliant and so on. So you could do that, and it will give you a result of how your clusters are doing. But the results are not very granular. It just gives you a pass or fail. So this is something that we're going to work with the Rackham team. And in the future, we hope that Rackham will be able to deploy the compliance operator by default. That would be great. Right, that's all, folks. Thanks you all out for listening. I think the Q&A will be part of another section in the conference, not part of this recording. But thank you for listening. Have a good day.